Digital Signal Processing Lab. Lab number 1 submitted to Dr. Jamil Khan, submitted by Chaudhry Mohammad Uzair, registration number 20TE38.
Is to describe you what I am going to describe you. So first task, I describe the time interval from 0.01 to 1. We have taken the frequency is equal to 1. And you've seen we have to describe a signal. So here we take a signal, sine signal of in this we use uh, f multiplied by 2 multiplied by 2 pi t. This is basically a sine signal. Now we have to use plot command to plot the output of the signal. Here we use one axis the time axis and the other one is the signal we have used the sine axis. So when we like this input, the signal shown to us is the sinusoidal signal in between time and sinusoidal. The second task is to add the titles and X and Y labels to the existing task. So as we know, in previous tasks we have used define the time from 0 to 0.01 to 1, and frequency was 1. Here is the same frequency 1, and the signal is the same signal that we have used in lab task 1. So first of all, we plot a single T comma signal. From till this, it is same like the task one, but we have to add the titles and text labels and Y labels to this task also. So to apply title, we use the command title plot of sine wave 1 Hz. This will plot the title of the output, and in X label we use time in seconds, and Y label we use amplitude. Here we define the axis of x and y. Minus 0.05 to 1.5 is the axis of x-axis, and minus 1.5 to 1.5, as we can see in the output, minus 1.5 to 1.5. It is the interval of the y-axis amplitude. So when we apply this code in the command window, we see this output. We can see there is an interval of minus 0.1 to 1.5 in x-axis and minus 1.5 to 1.5 y interval. To 1.5 in x-axis and minus 1.5 to 1.5 to y interval. And here we can see we have here plot of sine wave title is given, and x y amplitude title, and by x label title is also given. So the output of this is sine wave also in this given interval of time. Now moving towards task number 3. Again here we use two signal. So first of all, the time is the same as we have used the previous signal, and as there are two signals, so we use two frequencies. F1 is equal to 10 and F2 is equal to 520. As there are two signals, we use separately to differentiate them. We use signal 1 and signal 2, so we can differentiate among them. First signal F1 frequency 10, which will use frequency 10, and signal 2 F2 520 frequency will be used. First we define the signal 1 and 2. Now we have to plot the signal. As we know, the command of the plot is T signal 1. This will plot the signal 1, and we have to plot the same signal on the same graph. So again we use T along signal 2. So the time axis will be the same, but the signal 1 and 2 will vary. And now we have to assign the title. As we can see, the output plotting multiple signals in one figure, x label and y label. For x's, we describe uh, we have described the limits and time interval from 0 to minus 1. Here we can see from 0 to 1, and in y 0 to 1. Oh, sorry, minus 1 to 1. This is an interval, and we have seen this the title and two signals are plotted on the same graph, and we have x label as well as y label. Now moving towards the lab task number 4. In this task again we have from the beginning we have in the same the time and frequency 1 and frequency 2, because two signals are taken. In signal 1 we have used frequency 1, and now we have to plot the signal in dots. So we have again used the plot command, but in addition with semicolon in dot. This will plot the signal, but in the form of dot. Hold on.
and then signal 2 will again we will plot a signal 2, and signal 2 R commands mean the dots will be happen but in the red color. And again we give the title to the this array. We do not need to describe anything else, but just we have to call our function. Now moving towards function max 8 lab task number 8. Here we will find the maximum element. It is same as the previous task, just it is different that first we set the first element is equal to maximum, and again we start the loop and check it's the loop check if an element is greater than first element. If so it will replace it in the maximum value. This two will continue till the end of element and store the maximum value in the max, and this loop function will complete. Again, we describe this our array and just call m is equal to my function x. Here it will this law will work, and as we know 9 is the biggest element in this, the maximum value will be displayed to our command window. Now we have to find the average of the array. It is again we use a function. We name it my average. N is equal to length of the x. As we know, the average is equal to sum of all the elements divided by number of elements. So first we describe the n is equal to ln of x, length of x, and we sum all of the element in the array and store it in sum of x. Now we take the average. We know sum divided by total number of elements. This will the formula, and we will save this function as my average. Now we use the array in the command window and just call my average. So it will implement the whole process and will give a sum and average of this array. Now lab task number 10. Here it is simple task. We have to sort our array. We use the function sorted and name is my sort of x, and sorted is equal to sorted of x, and then store this in the MATLAB computer, and then just in the command window we use our array x is equal to 37529 and call the function my sort of x. Here this function will be sorted and will be displayed to us 23579. Now lab task number 11. In this task we have to reverse our array. We use the function reverse and name it my reverse, and again uses the reverse x and minus 1 to 1, and this will reverse our array. As we know this is our array and we just call the function my reverse. It will give output 92573. It will reverse our array. Now lab task number 12. Here we are interested in two signal to plot subplot two signal. Here the time is the same. X is a random signal from 50 to 1, and Y is time toward lab task number 6. Now basically task number 6 from onwards till I think so 11 or 12. These are tasks are uses of function. Function basically first we make a function and save in this our MATLAB on our computer. Again, then we have to set the function. We just call the function and easily implement the data. So here we can see that function, and we have created a function max element, min element, and we have named this as my function x, and maximum element is equal to maximum of x and minimum element is equal to minimum of x, and then end of this command. First we have plotted this describe this function and save in this by the name of my function dot n. Now in the command window, just I have to use the big small my function, call my function, and this is the array from where we have to find the big and small element. As we use the my function command, it will go to this function and check what is in this function, and it will first show us the big element, which is 55 over here, and then minimal element, which is 3. We are not we will not write anything else, just we have to call the function and give our array. Now lab task number 7. In this task we have also used function of my main name. In this task we are interested to find the minimum element from the array. First we describe the function over here. Function of main is equal to my main of x, and first we set the minimum value x of 1, and we start the for loop from first element to up to an element of the array. If we find any element of in the array less than the first element, we will replace it with that element and store it in the main value. This loop will work until it completes. It will reach the last element, and we will find the minimum element. We will set this function, and we will store the function within the name myMain. Now we have used this array x is equal to 37529, and we just call myMain function. When we call the function, we just get the output our 2 here, which is the minimum element in this array. We do not need to describe anything else, but just we have to call our function. Now moving towards function max8 to the task and x label and y label and axis, as we know, 0 to 1 in the x interval and from -1 to 1 in the y interval. Here we can see the output. We have red and blue signals. The red one, the signals are the signal 2, and the uh, blue ones are the of signal 1, as we have discussed in the code. Now moving towards lab task number 5. So in this task we have used the comments also. As we know that many codes we have to use this comment section so that the other users who uses the code easily can understand what we have discussed in the code. So in this task, we have used the comments. For the comments, we use it as percentage sign, and after the percentage, we what we write over here, it is in the comments. It is not the part of this part of the code, but basically it will help the user to understand what is happening in the code. First, we have used written over to generate random data from a uniform distribution, and then again percentage and calculate the mean, plot the data and the mean. From here we can see what is happening in the code. We are taking the random number and taking the mean and then plotting the data and mean. So here n is equal to 50. Again percentage sign, we have given a comment here that 50 data points are here. Now random. Random number we will assign from n is equal to n 50 to 1. Plot command will assign plot the our signal, and mean we have taken the mean is the average. Also we can also call average of the signal. Okay, now we have to define the limits of interval from where to where we have to plot. Draw a line from 0 to m, and this is the command, and for this to implement we use the command plot 0 to n comma m to m, and hold off that for the, and in the last we have used the title, so which appear in the top of the graph. Title is the mean of random uniform data. From the output, we've seen that the mean of the signal, the random signal, is at point below point 0.5 is a straight line in the constant straight line. This is the mean of this random signal. Okay. Now moving toward lab task number 6. Now basically task number 6 from onwards till I think so 11 or 12. These are tasks are uses a function. Function basically x length of x, and we sum all of the element in the array and store written sum of x. Now we take the average. We know sum divided by total number of element. This will the formula, and we will save this function as my average. Now we use the array in the command window and just call my average. So it will implement the whole process and will give a sum and average of this array. Now lab task number 10. Here it is simple task. We have to sort our array. We use the function sorted, and name is my sort of x, and sorted is sorted of x, and then store this in our MATLAB computer, and then just in the command window we use our array x is equal to 37529 and call the function my sort of x. Here this function will be sorted and will be displayed to us 23579. Now lab task number 11. In this task we have to reverse our array. We use the function reverse and name it my reverse, and again uses the reverse x and -1 to 1, and this will reverse our array. As we know this is our array, and we just call the function my reverse. It will give output 92573. It will reverse our array. Now lab task number 12. Here we are interested in two signal to plot subplot two signal. Here the time is the same. X is a random signal from 50 to 1, and the Y is sinusoidal signal 10 to pi t. And we have to plot these two signals. So X subplot 1 to 1, this will plot x plot x and again subplot 1 2 2. As we know, we have used the plot command to little plot to figure on the same two graph on the same panel. Now, moving toward the final task, which is lab task number 4, we are interested to draw the fourth subplot uh, of 2 ratio 2. Here we have used it, we can use it as anything else 1 ratio 4 or 4 ratio 1, but we have used it the 2 ratio 2. 2 is the row, 2 and 2 is the column, and 1. This is a fun. Again, the 2 ratio 2 and 2 and 3 and 4. If we use it the 2 ratio 1, 2 ratio 4, something else, it will be displayed this output. So by this, our 13 task score completed. Meet you in the next video. For this, stay tuned, press the bell icon, and do support us. Thank you. Allah Hafiz.